All right, we're going to talk about the different parts of the what's called the Cartesian plane. So there's two different things that we call the Cartesian plane. We have, and this is, I think, how it's spelled, it's also often called just the XY plane. And the reason that it's called the XY plane is there's usually two axes. Okay, and so this horizontal one is called the x-axis, and this vertical one is called the y-axis. So that's where we get the XY plane. Now, the axes, these are real number lines. So we have the two number lines meet at 0, 0, and we call that the origin. And then we have the x number line that counts out from the origin in both directions. And then in the y direction, it counts as well. It's getting kind of busy down here on the bottom part. Okay, now these two number lines divide the plane up into 4 parts, and we call each part has a different name. The upper right part is called quadrant 1, because again, quadrant has to do with quarters. So quadrant 1, and we go counterclockwise. So the upper left is quadrant 2, the lower left is quadrant 3, and the lower 4 is, or the lower right is quadrant 4. Okay, so what we do with the XY plane is we plot points on it. So the points are called ordered pairs, and it's called ordered pairs because, well, they come in pairs, and the order is important. So the point 1, 2 is different than the point 2, 1. So if I were to 1, 2 would be 1 unit to the right, and 2 units up. So that would be right there. That's 1, 2. And then 2, 1 would be 2 units right. And up 1 unit. So that would be 2, 1. So the order is important, and that's why we call it an ordered pair. So the first number, the x number, tells us how many units to the left or right. So the number of units we move left or right from the origin. And then y tells us the number of units we move up or down. And so, by the way, the origin is the ordered pair 0, 0. So let's graph some different pairs. So here's some different ordered pairs. So the origin is there at 0, 0. This is the x-axis. This is the y-axis. So this point 1, 5, I move 1 unit to the right and up 5. 2, 3. This is in quadrant 1. So minus 2, 3 means I move 2 units to the left and up 3. It's in quadrant 2. Minus 3, 4, I'm going to move 3 units to the left. So there's 1, 2, 3, and down 4. 1, 2, 3, 4. That's in quadrant 3. Oh, I wanted to make that 4, negative 2. So 4 to the right and down 2. And this point's in quadrant 4. Now, some points are not in a quadrant. For example, the point 0, 3, 0 is the number of units I move left or right, and 3 is the number of units I move up or down. Since it's positive, I move up 3. Then I could have, so this is on the y-axis, so it's not in a quadrant. I could have minus 4, 0, and I'm going to start at the origin and move 4 places to the left, and then 0 units up or down. And this one's on the x-axis. All right. Now to talk a little bit about graphing equations. So if I have the equation 2x plus 3, I want to graph that. If I'm doing it by hand, I need to just choose some x points. So I might choose minus 3, minus 1, 0, 2, and 4. And then I'm going to take each one of these x's and plug it in right there, and that's going to give me the y value. So that's going to be minus 6 plus 3 is minus 3. So don't forget we have to use the order of operations as we do this. So 2 times minus 1 is minus 2, plus 3 is 1. 2 times 0 is 0, plus 3 is 3. 2 times 2 plus 3, that's going to be 4 plus 3 equals 7. And finally, 2 times 4 plus 3 is 8 plus 3 equals 11. So I get 4 ordered pairs. So what I'm going to do is bring this over here, and the actual xy pair is going to be minus 3, minus 3, minus 1, 1, 0, 3, 2, 7, and 4, 11. So there's my ordered pairs. And I'm going to go to an XY coordinate system, and I'm going to graph each one of those ordered pairs. So there's -3, -3. We get -1, 1. 0, 3, 2, 7. So 0, 3, 1, 2, 3. I think it was 2, 7, 4, 5, 6, 7. And then finally 4 and 11. There's 2, 3, 4, 8, 9, 10, 11. Okay, so my scale isn't real good. I'm just going to kind of connect the dots. So this should be aligned, but you know, it's not really drawn to scale very well. But that's how I would graph. This would be the equation y equals 2x plus 3. Now, we have several parts of the graph that I want to talk about. This point where the graph crosses the x-axis, so remember this is the x-axis, and where the graph crosses that is called the x-intercept. Now we can have more than one x-intercept. And under certain conditions we can have more than one y-intercept. The point where the graph crosses the y-axis is called the y-intercept. Okay. Now I don't know from, since this isn't drawn to scale, I don't know from looking what that point is. I could probably guess and check, but we'll save that for something another time. Okay. Let's look at y equals minus 2x squared plus 3x minus 1. Okay, so this is the equation that I want to graph. So again, I start out. I'm going to choose some x's. Let's see. -3, -2. And so I can really pick about anything I want for the x's. There's some like bad choices where you're going to be you're not going to see anything interesting. They're supposed to be indicative. Okay, so let's review order of operations real quick. Exponents first, so that's going to be -3 squared is going to be 9. So we get -2 times 9, and then -3 times 3 is 9, -1. So -18 -9 -1 is -28. So that's a really big number. -2 times -2 squared plus 3 times -2 -1. Okay, so that's going to give me -2 times 4 -6 -1. So -8 -6 -1 is -15. -2 times 0 squared plus 3 times 0 -1 is going to give us -1. 0 squared is 0, and then -2 times 0 is 0. 3 times 0 is 0, leaving us -1. -2 times 1 squared plus 3 times 1. minus 1, so that gives us minus 2 plus 3 minus 1, 0. All right, I don't think we're going to do 3 here. Let's stop after this one. So everywhere there's an x, I substitute in a 2. So this is going to give me 2 squared is 4. 4 times minus 2 is minus 8. So I have minus 8 plus 6 is minus 2. Minus 1 is finally minus 3. So I have the ordered pairs minus 3. Oh, I didn't count. Yeah, I did. So I have the ordered pairs minus 3 minus 28, minus 2 minus 15, 0 minus 1, 1, 0, and 2 minus 3. So I'm going to go to the next page with that. And so I'm dealing with really large negative numbers. So I'm going to put the axis kind of up here. All right, this is the x-axis. This is the y-axis. So minus 3 is going to go this way. And then minus 28. So just pick something way down here. Minus 2 minus 15. So there's minus 2. Minus 15 is just a tiny bit more than halfway. We have, looks like 0 minus 1, 1, 0, and 2 minus 3. And now I connect the dots. Now I may be familiar with a parabola, so I didn't capture the vertex. Well, but anyway, so that's a really terrible parabola. But that is how we graph. That's graphing by hand.